Alright, so welcome into our next video, and here in this section we're trying to work toward helping our students increase their math reasoning skills inside the math classroom. So one great way to do that is to give them a method for solving problems that they can use no matter what, no matter where they are, no matter what they're doing, whether they're taking a high school equivalency test, taking the college placement test, or something in the workplace. This method will work. We're actually going way back in the past. A mathematician named George Polya first developed this method, and we've updated it thanks to Kim Litz from AB Tech gave us a more catchy name for this. We like to call this the UPS check method. And of course it's another acronym, UPS in check. The U in the UPS check method stands for understand the problem. Understand the problem. So essentially, what is the problem asking us to do? Maybe it might even help us to draw a picture to understand exactly what it is that the problem's asking us to do. If necessary, could we rewrite the problem maybe in our own words to get a little bit better feel for what it is that they're asking us to do? So step one, we've got to understand what it is they're asking us to do. Step two, plan. Got to plan. Because remember that old saying, if you fail to plan, you plan to fail. So we've got to create a plan. And this is where those strategies that we talked about earlier, teaching students these specific problem-solving strategies, really come into play here. You saw on the graphic organizer a number of the strategies. The four of my favorites are the guess and check method, which especially works well on a multiple choice problem. You could take the various ones, plug it back in, see which one works, and there's your answer. I love that. Drawing a picture or a diagram. Doesn't matter if you're a great artist, could you draw a picture to kind of see visually what's going on? And since most students are visual learners, that works well. Make a table like we did earlier with the Hartley food truck problem. And other one is act it out. You could get the students to play these roles and interview them about what it is they're doing and what problem we're trying to solve. And if there's multiple people, get multiple folks up. That's a great strategy. So we're creating some kind of a plan using one of those strategies that we can be teaching our students as they go on through our math class. And then finally, we actually solve it. We do the steps necessary in order to solve. And really, we can help our students by not being the person who dives in and shows them what the answer is, but let them struggle a while. Help them ask questions as necessary, like we saw in the Teaching with Questions video, but be patient with them and help them develop that persistence, that grit that they need in order to be successful problem solvers. So once they solve it, the last part is check. Understand, plan, solve, check. And so the last one is, is going to check, does the answer that we had make sense? Did we do all our calculations correctly? What did we learn from solving this problem that we could use in the future as we solve other and different problems? So we've got that. We have the graphic organizer that outlines it as well. So let's put it to the test. Let's say I had a problem. Let's say I was going to go to the store and buy this lovely chair that cost $139.99. Wouldn't that look great in the living room, family room, whatever? So we've got this $139.99 chair. Now we have from the store two coupons, one which says 20% off, the other which says $20 off. And our problem asks us, for buying this particular chair, this roughly $140 chair, which is our better coupon? Is it the $20 off, or is it the 20% off? So that's going to be the task we're going to use our UPS check method to try to solve. So first step is understand the problem. So let's see. I think I understand the problem saying is we have a chair that's $139.99. Now, I am going to make this chair $140. Doing it as a penny is not going to change things a whole heck of a lot. So I've got a $140 chair, and what I'm being asked to see is, would it be better to use a 20% off coupon or a $20 off coupon? I'm going to switch out my pens here. So let's see, you got a $140 chair shop. The choice is $20 off a better coupon, or is 20% off a better coupon? So that's essentially which one of these two things is better, $20 off or 20% off is the better coupon. Okay, well, I'm going to have to now set up a plan in order to have to solve this particular problem. So let's see here. I think it might make some sense if I did a comparison. If I figured out what it would be with $20 off, and I figured what the cost would be of the chair if we took 20% off. So my plan is essentially, I'm going to do a comparison. I'm going to do both $140, where I'm going to take away the $20, and then I'm also going to do the 20% of the $140 and see which one gives me my better deal. Do a little comparison. So I understand the problem. I've set up my plan of what I'm going to do. Now I'm actually going to go ahead and solve it. So I said I was going to take my $140 and I was going to subtract from that $20. And let's see if I do that math. That's going to give me $120 as my take-home price for that. Of course, we've got tax, but the problem didn't say anything about that. So just said which one of these coupons is the better deal. The other one says 20% off. And so I'm going to use my math tool strategically here. So I'm going to do in my calculator here 20% times 140 and see what I come up with. The calculator says I will come up with $28 off. So let's see, so I had my $140 chair, and this particular one with 20% off is going to save me $28. If I went ahead and did my subtraction, I'd end up with $112. So I said in my plan I was going to compare which of these two is the better deal. So let's see here. Looking at that one, it sure looks to me like 112 is less than 120. So 112 is my better deal. So I'm going to take, and this was representing the 20% off, so I believe I'm going to go ahead and say that 20% off is my better deal. And so I can go home with a few more dollars in my pocket, buying that chair for $112 plus tax versus buying it for $120. So now, last but not least, I need to check and make sure that I'm right. So I can go back, make sure I really understood the problem. It's asking me about these various coupons, which one's the best. I think I have a good understanding of the problem. Well, let's see, calculations, any error? Let's see, 120 plus 20 is 140. I can go back and review. Let's see, maybe if I did the calculation again, 20% times 140. Yeah, it verifies that $28 is correct, so we know we're good there. Did I do my math well here? 112 plus 28. Let's see, 8 and 12 is 20. 20 and 20 is 40. That's checks, that checks. So I know my math is good. And is 112 lower than 120? Yeah, I believe it is. So I feel I'm in good shape with that one. So always an important step to do on the check. Sometimes students don't do that a lot of times, but it is very important because a lot of times we do make mistakes when we're rushed, we're nervous, whatever. So teaching our students the UPS check method or the POLIA method, whichever you prefer to say, gives them a framework that they can use no matter what problems they solve. Definitely be something great to help them with increasing their math reasoning skills in the math classroom. Give it a try with your students. I'm sure now that they have a method they can use no matter what, are going to like it and do better as they face whatever they have to do in their futures.